Hello and welcome to another video. In this video we're going to be working on student attendance record 2. And in this one, an attendance record for a student can be represented as a string where each character signifies if a student was absent, late, or present. The record only contains the 3 characters absent, late, or present. A student is eligible for attendance if they meet both of the following criteria. A student was absent for less than 2 days, and they can't have a streak of 3 lates. So given an integer n, return the number of possible attendance records of length n that make a student eligible for attendance award. So with only 2 days, you can't have a late streak of 3, so that's not possible. So the only one that wouldn't be valid here was AA, because then they'd be absent twice. Everything else, every other combination is fine. And for 1, you can either have present, late, or absent. So any one of those is fine, and then they give you some big number. So essentially, you basically have 3 choices at each thing. And the first thing I wanted to think about was, is there a way to do some kind of combinatorics thing? Like, I can be like, okay, well, maybe if, like, let me figure out, since they can only be absent once, maybe let me figure out how many ways they can be absent 0 times and how many ways they can be absent 1 time. But the problem is this late streak. So with this late streak, there's a late streak in all kinds of places. And it's basically makes it kind of impossible to do a combinatorics thing without actually doing some kind of, like, loop. Like, for example, let's say you have like a million things. You might have a late streak of 2 here. You might have a late streak of 1, late streak of 2 here, and so on. So there's way too many combinations, and there's way too many possibilities to just like count a number. So then the other thing I thought was, okay, well, at every situation, I can either put in a absent, late, or present. So that sounds like DP. So let me try to do that. And that's kind of like what we're going to discuss here. So essentially, when this is this, you want to think about for DP, like, you know that you need an O of n, like you need states in the solution to not have it get a TLE, right? And so you can't, like, you want to think like, what's the minimum I can store to represent that? And so obviously you're going to need to store like what day you're on. I think that's kind of straightforward, or some kind of information about that. So that's already O of n. So if you want to store anything else, it needs to be tiny, like it needs to be like log n or something like that. And so let's think about what information we need to determine if these states can be used. So if we're on a day, we can always pick present, right? Like if we got to a day somehow, this is always allowed, because this won't increase absences or a late streak or anything. But what information do we need to know to say the student was absent? So we need to know how many absences they have. And these constraints make it good enough to do DP, because if you see, they have to be absent for less than 2 days, which means the only valid days are 0 or 1 absences. So we can actually store the index, and we can store the absences as well, because there can only be 0 or 1. There can't be that many. So it's okay to add this variable because it's tiny, right? So if this is like 10 to the 5th, then this will be 10 to the 5th times 2, which is fine. Okay. So what information do we need to know if we can give them a late day? And so for a late day, if you think about it, the only information we need to know if we can give them a late day is what's their streak of late days, right? So they can't have a late day if they were late for 3 or more. So, sorry, they can't have 3 or more lates. So this late day streak can only be 0, 1, or 2, right? Because if it's 3, they're ineligible. So we can also add this information as well, because it's only 0, 1, or 2. So late day streak. So we can have a DP function where we have an index, which is 10 to the 5th, which is fine. Let's just actually write it like this. So 10 to the 5th. Absences will only be 0 to 1, and late day streak will only be 0 to 2. So that's totally fine. So these are our states. Now what's our base case? So our base case is pretty straightforward. Our day is n, right? Like we'll go from 0 to n, in which case we can just return 1 because we made it to a successful state. And our recursive case is we can either go to present, so we can always go to present. We can go to absent if the number of absent days is less than 1, because they can only have 1. And we can go to late. We can go to late if the number of late day streak is less than 2. And if we go to present, what would these values be? So present would look like our index would go to index plus 1. Our absences would stay the same, so let's just call that A. And our late day streak would be 0 because we just got a present. So if we go to absent, our index will go to index plus 1, our absences will go to absences plus 1, and our late day streak will also be 0 because we have an absent. And our late day is, our day will go to plus 1, our absences will stay the same, and our late day streak will increase by 1. And so that's essentially all you need to do. So you just do a DP function and you check, can I go to all of these? You can always go to this, and these you won't always go to. And so I'm actually going to show you the solution in Python, and then I'll talk about why and some issues and things, and then we'll go into like the next part of it, which made it actually a hard problem. Okay, so let's take a look. So here's the Python solution, and we're going to ignore all this. So let's just do this. So essentially, it's pretty easy. Like I'd say this is closer to a medium problem for just this. So you have a mod value. We have the index, the absent count, and the late streak. If we made it through all the days, we just return 1. Then we check, can we go to an absent day? We can if we have 0. So we'll just add that value and mod it. Can we go to a late day? We can if our late streak is less than 2. Same thing. And finally, we can always go to a next present day. That's always going to be allowed. Then you just return it, and this will work. So our initial state is day 0, no absences, and no late streak. So if we actually run this, I think I need to, yeah, let's just get rid of all this. All right, let's just do this. There we go. Okay. So the thing I ran into, now this might pass in another language. I haven't tried in Java, to be honest. The thing I ran into is actually a TLE, which was kind of, or a memory limit exceeded, which was kind of surprising because I thought this would be like fine because this is 10 to the 5th. And then, like I said, this is like only 0 or 1, and this is only 0, 1, or 2. So I thought this would be fine. But a thing you could recognize here is, okay, so we got a memory limit exceeded. So the memory limit exceeded means our space is too much. So this is one of those rare cases where I'll show you how to do bottom-up DP and like space optimized bottom-up DP. I usually don't do it for problems because I've done it enough and I have like videos on it. But in this case, I basically realized like, let's look at all of our recursive cases. So all of our recursive cases actually go to the next index, and then these values change. So because all of our recursive cases actually go to our next index, instead of storing the index, we can just store the states of absent count and late streak. And then for the next day, we could just figure out like what will those be. So let's kind of walk through a few of those in a picture and show you what I mean by that. So basically what's going to happen here is we actually need a 3x2 matrix here. So let's take this. So let's say our absent count, let's get rid of this. Okay. So we can represent our state instead of like we can represent our state for a day in this matrix, and that's it. So the rows will be absences and the columns will be late streak, right? And these are all valid. So we can have 0 to 1 absences or a late streak of 0, 1, 2. And this is basically all the information we need to represent, let me actually copy this as well because we're gonna need it later. This is all the information we need to represent like the total counts for a day. So at, like before we go anywhere, these are all 0, right? So this is all 0, 0, 0, 0, 0, 0. Then at day 1, we have 3 choices. We can either go to present. So if we go to present, what will that represent in this thing? So if we go to present, that means that, oh, by the way, so these values are like the counts of like ways we can get here, right? So in the beginning, we didn't do anything, so these are all 0. But at day 1, if we go to present, that means we have 0 absences and 0 late streaks. So this value will be 1, right? Because this will basically mean day 1 was present. Now, what if day 1 was absent? So if day 1 was absent, then it's going to be this case. We're going to have 1 absence and no late streak. And if day 1 was late, that means we have a late streak of 1 and 0 absences. So this is what the state looks like after 1 day. And for day 2, we can basically make another one of these, and this is all the space we're gonna need. So we're gonna say like, okay, for every new day, let's make a new one of these. Let's go through our old matrix and let's just take every single value and let's say like, okay, what if I was here and then I was present? What if I was here and then I was absent? What if I was here and then I was late? And let's get the values for day 2 and then do that for day 3 and so on. So you're only storing a matrix of 6 values, so your space becomes basically O of 1. So let's kind of show you how a couple days will work here. So this is after day 1. Now for day 2, we're going to say, okay, let's go through all these values. So let's take this value, for example. So this value means we have no absences and no late streak. Okay, well, from here, we can either go to present, absent, late. So what happens if we go to present? Well, if we go to present, then this will basically go right over here, right? This will go right over here. So if we go to present, this value will be 1. Okay, what about for here if we go to absent? So if we go to absent, then this value will go over here, right? It went from 0, 0. Now we need to update the absences, so we'll have 1 absence. So this will be 1. Now what happens if we go to late? So that will go over here. So let's do that. Okay, now for this value, so this value represents 1 late day or 1 late day streak and 0 absences. So what happens if we go to present from here? So if we go to present from here, our late streak will reset to 0 and our absences will stay at 0. And this is 1 more. So basically, this is going to go from here to 0, 0. So this will be 2. Then from here, what happens if we go to absent? So if we go to absent, our late streak will reset and our absences will go to 1, which is fine. So that will be this case. So we'll add 1 more here. Now what happens if we are late again? So if we're late again, our absences will stay at 0 and we'll have 2 late days, which will be over here. Now for this value, what happens if we're present? So if we're present, our absences will stay at 1 because we can't delete absences. Our late streak will be 0. So we'll stay at this box. So this will go to 3. Now what if we're absent again? So we can't be absent again because we're already absent once. So that would be invalid and we can just ignore that case. And then what happens if we're late? So if we're late, we'll have 1 absence and we'll have a 1 day late streak. So that's this box here. So this will be the state after day 2. And we can say like, okay, well, if this is all the possible states after day 2, we don't really care about all the states after day 1 anymore, right? We can just store this. And then for day 3, let's do one final one. For day 3, we can build this again and we can keep doing this and we'll have this box at the end of the last day, and then we can just add up all of these numbers, and that's like all the states you can have, and that's your answer. So let's look at this for day 3. So for day 3, let's say we started here. So we had 2 ways of being, we had 2 ways of having no absences and no late streaks. So let's say from here, we choose to be present again. So that will just go here, the same number that was here. Now, if we go to absent here, that will go from here to here. So we'll have 2 over here. And if we go to late streak, that'll be over here. Now from here, what if we choose to be present? Which this means our late streak will go to 0, our absences will go to 0. So that's going to add 1 more over here. What if we choose to be late again? That's going to add over here. And what if we choose to be absent? Then our late streak will reset and we'll be absent over here. Now hopefully I did these counts right. Maybe I screwed something up, but essentially you get the point. So there's 2 more here. So here we have a late streak of 2. What if we choose to be present? That means our late streak will reset and we'll go to 0, 0. So that'll be 4. What if we choose to be absent? Our late streak will reset and we'll have 1 absence. So that'll be 4. And what if we choose to be late again? We can't, because we can't have 3 late days. So that will be invalid. Now here, if we go to present, or if we go to present, we'll still have, so this state was actually, we had 1 absent and 1 late streak. So if we go to present, our late streak will reset and our absences will stay the same. So we'll go over here. If we are absent again, we can't do that because then we'll have 2 absences. And if we are late again, our late streak will go over here. So go over there. So I believe I did this right. I think. Yeah, hopefully. Maybe I missed something, but essentially that's kind of the idea, is you basically go through all the stuff for the old day and you just check like, can I go from here to present? Can I go from here to absent? Can I go from here to late? And which box does that end up in? And just update the value of that box. And at the very end, you will have a value over here. So like I said, maybe I miscalculated something, but essentially at the end, you'll have this matrix after n days. And then you can just sum up all of these values, and that's your answer. So let's take a look at the Java solution for that. And basically, you can realize this is O of 1 because we just have a 2x3 array. So we got rid of that whole n dimension, which was like 10 to the 5th. So this is the space-optimized dynamic programming solution. So let's take a look at that in Java. Okay, so we have our mod value, we have the max absences we can have. So this is one more, right? We can only have one absence. And this is the max late days we can have. So this is basically the rows and columns of the matrix. So the rows will be the absences and the columns will be the late days. Then we make our DP and we say for our first day, we have 3 possibilities. We can either be present, which is 0, 0. We can be absent, which is 1, 0. Or we could be late, which is 0, 1. Then we just loop through every other day. And for every other day, we make a new matrix. And then we say, okay, let's get the value in our current matrix, which is just, so let's delete some of this. Let's get the value in our current matrix that we're currently on, maybe like this cell. And we'll say, okay, so if that row is 0, remember row is the number of absences, that means that we can go from this cell to absent, which will go to row plus 1, 0, right? Like if we're on some row here, we have to be on row 0. We can't be on row 1. If we're on row 1, we can't go to absent because we can't have 2. But if we're on row 0, where do we go? We will go to row 1 and over here, right? Our late streak will reset and we'll have 1 absence. So that's basically this. So we'll go to row 1 and 0 late streak, and then we'll add whatever value we had. So we just get the value that on for our current cell, and then we add to our new matrix whatever was in there before plus the value of this. Then the other thing we check is if our column is less than 2, which means we have less than 2 late streak, right? So if we're not on this column, then we can just add 1 more to the late streak. Where will we go from there? Whatever cell we're on, we will just go to the one to the right. We'll add 1 to the late streak. Whatever we're on, we'll go 1 to the right. And that's what we're doing here. So the same row, and we'll just go 1 to the right, and we'll add that value. And then finally, we have our just state going to present, and that's always allowed. As long as we were at a valid state, we can always go to present. Where do we go from that? We stay on the same number of absences, and our late streak drops to 0. So these are our 3 conditions. We can either go to present, to absent, or to late. And at the very end, we will drop, like once we fill this table out, we will drop our table for our old day, and we'll just store this one because we no longer need it. Our current day only relies on the previous day. That's why you can space optimize this. So then we just say DP equals new DP, meaning like what's going to happen here is this was our old DP. This is new DP. And we'll say now let's make DP equal to this and drop this table here. And then for the next day, we'll make another table here. This will be new DP. We'll fill it out, and then we'll say DP is equal to this table now, and drop this, and so on and so on and so on. And then finally, your DP will be your table after n days, and then you just add up all of these numbers. So that's the last part here. I just got a total, and I go through my final DP, and I just add up all the values. And in Java, I think you probably have to be careful. You have to mod like kind of consistently. You have to mod all the time because you can get an overflow. In Python, you can just do a mod at the very end if you want to. But that's essentially what I did. So I basically did a, I usually code this in Python and then I do it in Java because I knew this would be pretty fast. So I coded it in Python, got a memory error, and then was like, okay, well, I'll probably have to do bottom of DP. I don't really see any other way around it to save some space. So maybe the memoization for Java passes, but also kind of show you once in a while how to do bottom of DP. And like I said, this is space optimized, so let's go through the time and space for this one. So the time is basically for every single day, we make this like 2x3 matrix. So this is O of n because the 2x3 matrix is so small. And the space is O of 1 because we are only storing a 2x3 matrix now, right? Like this DP is only a rows times columns, and rows and columns only a 2x3. So we can submit this thing. Yeah, and let me know if some Java solutions or if some Java solutions pass with memoization. I think if you code in a faster language than Python, memoization might pass, but on Python I got the memory exceeded. So maybe if you code in like C++ or something, it's less memory. I don't know. So this is pretty good. There are some solutions in here, and I think they use something called like a power. Like matrix power or something, which I haven't seen, so I'm not gonna go through that. But yeah, I think that's going to be all for this one. So hopefully you like this one. And yeah, I think this definitely makes it a hard problem because you have to do space optimize bottom up DP in order to get it to pass in Python at least. Maybe in Java you don't. Memoization is probably closer to a medium. Yeah, space optimize bottom up DP. If you haven't done it, good one to practice. And this is also a unique case where this is a 3D DP, so it's trickier than most to get all the cases right. because normally you have like a 2 DDP and you get rid of one dimension and then it's kind of straightforward. But here you have a 3 DDP, so I think drawing this out and like visualizing what's going on. I am trying to, like, currently I don't draw these out. I try to just think about what it would look like, and then I just draw them out for the videos, because I think drawing them out while doing them takes very long, and I think it's good practice to try to like figure out, okay, what does this look like in my head, and trying to get it, and it did work. And I'm getting better at that, but I usually don't do bottom up DP because the gain you get is pretty negligible. I mean, you get like a little bit of performance gain, but as far as like the time it takes versus memorization's 100 times faster, so I just focus on that. And yeah, that's going to be all for this video. Hopefully you liked it. If you did, please like the video and subscribe to the channel. And I will include the Python memorization solution as well. And yeah, so thanks for watching, and I'll see you in the next one.